Hello friends, so today we are going to solve the question for rotational motion, and this question is from year 2022. One question we are going to solve, and this is from the advance. PYQ. And the question is, a solid sphere of mass 1 kg and radius 1 meter rolls without slipping on a fixed inclined plane with an angle of inclination theta 30 degree from the horizontal. Two forces of magnitude 1 Newton each, parallel to the incline, act on the sphere, both at a distance r 0.5 meter from the center of the sphere, as shown in the figure. The acceleration of the sphere down the plane is, I forgot to paste the picture, I will draw it approximately. So we are having an inclined plane, and the angle of inclination is given as theta, which is 30 degree, and we have a sphere, and suppose this is the center of sphere, and we have two forces. One will be acting in the downward direction and other one is acting in upward direction, and both are at the equidistance from the center at a distance of 0.5 meter. Okay, so both the forces will be at the same distance. Okay. So this is the basic, and 1 Newton each. So both the forces acting are having the same magnitude. Okay, so this is the basic figure, and it says that it moves down the plane, and we have to find out the acceleration. And first of all, because it says that there is a without slipping, so let us find out the translational motion. And for translational motion, okay, let me draw the basic figure, and we have to remember this is with respect to the inclined plane. So there will be a force mg which will be acting vertically downward, and this mg we can divide into two components, and we have this angle as our theta, so this will be theta, and we are going to have this as our mg cos of theta, and other one will be mg sine of theta. And let us suppose we are having two forces, and this force we are calling as F1, and the force which is acting upward, let us suppose calling as F2, and there will be frictional force that will be acting in the upward direction, let us we call this as F. Okay. So we are only interested in the along the inclined plane. Normal we are not going to consider for this particular case. Okay, that will be coming only because of the frictional part, but we can just deal it with later on also. So we have a translational motion and along the inclined plane. Inclined plane, and we assume that let the acceleration is given as ACM in the downward direction. So we can write the equation that our mass into acceleration will be equal to our mg sine of theta plus F1 minus F2 and minus of the frictional force. And F1, they are of same magnitude, so it goes away, and theta is given as 30, so we can just substitute it, and mass is given to us as 1 kg. Radius is also 1, so we get this as 1 ACM is equal to 1 multiplied by 10, and we have this as sine of 30 minus F, and this sine of 30 is our 1 by 2, so this will be coming as 5. So from here we get that our ACM is equal to 5 minus F, and in terms of frictional force we can write that our F will be equal to 5 minus ACM. Let us call this equation number 1. Now we come to the rotational motion. Rotational motion, or we can say torque about center of mass. About center of mass. So we have two equal and opposite forces which is going to form a couple that is going to produce as, and that is going to result in the torque, producing a torque, and these forces are F1 and F2. Okay. So we can say that two equal and opposite forces form a couple producing a torque. Producing a torque. Or we can also write tau couple will be equal to force multiplied by distance between two forces. Distance between forces, and each force is equal to 1, and distance between them is also 1. So this comes as 1 Newton meter, and there will be friction that will also producing a torque. Friction also produces torque. Let us call that tau F, which will be equal to friction multiplied by radius r. So which comes as F multiplied by 1, giving us our F. As there is a rolling without slipping, so we can find out our angular acceleration. So we have rolling without slipping. So we get our alpha is equal to ACM divided by R, and this will be equal to radius is 1, so it will be equal to our ACM. Now we can use the rotational equation with respect to the center. Rotational equation about the center. And that will be equal to our I alpha is equal to our tau net, and tau net will be equal to tau f minus torque of friction minus torque because of the couple. And our moment of inertia, we can easily find out that our moment of inertia will be equal to 2 by 5 mr square. Mass is 1, radius is 1, so this will be equal to our 2 by 5. And we get will be equal to 2 by 5, and our alpha is equal to our ACM. So we get this as our ACM is equal to tau of F is equal to F, and our tau couple is equal to our tau couple is equal to 1. So we get this as F minus 1. So from here we can write our friction is equal to 1 plus 2 by 5 times ACM. Let us suppose this is our second equation. So we have two equations and two variables, so we can easily solve it. Therefore, we can write from equation 1 and 2 we get our 5 minus ACM is equal to 1 plus 2 by 5 ACM. Now it's quite easy to solve, and we can just combine our ACM. ACM will be our 2 by 5 plus ACM, that is our 7 by 5. ACM will be equal to, and this comes as 5 minus 1 will be equal to 4. So we get that our ACM will be equal to 20 upon 7, and approximately this will be over 2.8 meter per second square. We can also find out our frictional force, because we already know relationship between ACM and this. I think it was not asked for. Yeah, so we get this as this is our 2.8, but anyways, let's solve for friction also. So we can say friction will be equal to 5 minus ACM, which will be giving us 5 minus 2.8, which will be equal to 2.14, and this will be up the inclined plane. So this question was asked in the year 2022 advance. So this completes the question. Thank you.